Hi folks, this is Nat, and this is going to be a video lesson on calculating the slope of a line. We're going to start off by looking at what slope is. So here we go. What slope is? Slope is basically a mathematical measurement of how steep and in what direction a line goes. So steepness is typically measured as rise over run. We'll talk about that in a second. It's how much a line moves sideways versus how much it moves up and down. And direction is given as a positive or a negative. Generally speaking, when we talk about lines, lines can move up to the right, down to the left. Those are positive lines. Or alternatively, they can go the other way, which is up to the left, down to the right. Those are negative lines. So the sign, the positive or negative of a line tells you a lot about it. As a quick example of what you can learn about a line, here are a couple quick ones. 3/4, if that's the slope of a line, that tells me that my line goes up 3 for every 4 that it goes sideways. So it moves horizontally a little more than it goes up and down, so it's getting closer to flat. It's also positive, that's not on there, but because it's positive, I know that it's going to be moving up to the right. -5/1, same idea. This tells me the 5 that it's going to rise 5 for every 1 that it moves sideways, so it actually moves up pretty vertically. And the negative tells me it's going to do that in the negative direction, up to the left. So you can look at the slope and know a lot about a line. It's a good measurement, very accurate. Let's look at how it's calculated. So here's a line. And for each of these, I'm going to have included a couple points that I want you to be using. And identifying what those coordinates are is going to probably be your very first step. So this is on a coordinate plane. So if we look at this first coordinate here, its x value is -3. So it's over -3. And then it goes down on the y-axis to -2. Okay. Here's my other point. It's +3 and -1. And we're going to be using those coordinates in a second to actually calculate slope using a slope formula, but there's an easier way to do it in a lot of cases, and in all of these cases today. So when we look at this line, basically slope is, again, a measurement of how much does it go over versus how much does it go up. And between these 2 points, which you can notice, hopefully, is that it goes over 1, 2, 3, 4, 5, 6 units, and it goes up 1 unit. That's what we call in math the rise and the run. The run is the horizontal distance, so in this case, this one has a run of 6, and the rise is the vertical distance, in this case 1. And one way that we can calculate slope, which we're going to use right now, is that slope, generally speaking, is going to equal rise over run. So if we know the rise and we know the run, we can calculate slope no problem. Here we had a rise of 1 and a run of 6. So this has a slope of 1/6, or 1/6. That's the slope of this line. Sometimes you'll have to add a negative on if it points the other direction. This is going up to the right, which tells me that this is a positive slope. And another way to think about it is that going from -3 to 3, as we move to the right, is going up 6. So it's +6 and then +1. It goes up 1. So those are both positives, +1/6. Give you another quick example. Here's another one. Okay, let's grab some dots here. We won't do the coordinates this time. We'll just think about the triangle or the rise and the run. Here are 2 points on here. This has a rise of 1, 2, 3, 4. Or alternatively, I might think of it from point to point here as going down 4, being negative 4. And same thing, going from left to right, it's going up 2, where it has a run of 2. So it has a rise of negative 4 and a run of positive 2, or negative 4 over 2. So in this case, its slope is going to be negative 4 over 2, or I could simplify that to just negative 2 over 1, or just plain negative 2. So slopes can be whole numbers. We assume a 1 under there if you want to know the fraction version. Something worth noting is this works no matter what. So let's imagine I'm using this point down here and going to this point up here. Now I have a drop of 8, point to point, and a run of 4. So if I calculated it with those points, it's negative 8 over 4, which hopefully you recognize is actually the same thing. Negative 8 over 4 reduces to negative 4 over 2, or negative 2 over 1, or just plain negative 2. So the cool thing about a line is it doesn't matter which points you grab, the slope fraction will always reduce to the same value, assuming you've done it correctly. We also have the ability to calculate slope using the slope formula, which looks more complex than it is. It's m equals y1 minus y2 over x1 minus x2. And it's really just a complicated way of doing the same sort of thing. But to do it, we have to grab 2 points. So let's go in real quick and identify 2 specific points. So here I've got negative 1, negative 2. So x value negative 1, y value negative 2. And this next one over, I have x value of 2, y value of 0. So we're going to call this first one point 1. And I wouldn't normally label these, but for the sake of making this point clear, I'm going to do that. The second one we're going to call point 2. So all this formula is telling us, when we look at this y1 and y2, those are the y values of point 1 and the y value of point 2. So it's telling me to subtract the y value of point 2 from the y value of point 1. And it's telling me to do the same thing with my x value, subtract the x value of point 2 with the x value of point 1. And it doesn't matter which you've decided as point 1 and which you've decided as point 2. We could reverse these if we wanted to. But you do have to keep it consistent for both the top and the bottom. So if I'm trying to fill this in, my slope is going to equal y1, so y value of point 1, that's this one, negative 2, minus y value of point 2. That's 0, so minus 0. And I'm going to put that over the x value of point 1. That's this one, which is negative 1. And I'm going to subtract the x value of point 2, which is that one. And if I simplify this, negative 2 minus 0 is still just negative 2. And negative 1 minus 2 is negative 3. So it's negative 2 over negative 3. 2 negatives cancel out, so we're just going to call this 2/3. It has a slope of 2/3, which we can actually confirm if we want to here, just because we have it graphed. We can see that there's a run of 3 and a rise of 2. Again, rise over run, 2/3. So we can see that either with the slope formula or with the just counting method that we've looked at here, the slope is 2/3 either way. Oh, one thing I did mention, or forget to mention, was the m value in here. M is math for slope. It's the variable that for some reason that all mathematicians have agreed stands for slope. So when you see m there, or here, that means slope. M equals slope. And that's pretty much it. Your practice for today is going to be to calculate a couple slopes. So here are 3 lines. The points are marked just to make life a little easier on you. Calculate the slope of the red, blue, and yellow line.